Okay, so in the last video, so I have explained about the unregulated power supply and the regulated power supply, and also what is the need for the regulated power supply is also been studied, and the actual block diagram of the power supply is also explained in the last video. Okay, and in this video, I am going to explain about the rectifiers. Okay, so that if you see the rectifier, so it is already explained while explaining the block diagram of the regulated power supply. Okay, so this rectifier, it is the process of converting uh, it is the process of converting the AC into the pulsating DC. So if you see the rectification process, so the rectification, it is the process of converting an alternating current into the pulsating DC. It is itself is called as the rectification. Okay, and if you take the types of the rectifier, it is to be classified. It is according to the uses of the diode here. So how many number of the diodes is going to be used in order to build the rectifier circuit? It is based on that one. So it is to be classified into of the main three types. It is one is the it is half wave rectifier, one more is the center tap, it is full wave rectifier, and the one more is the bridge rectifier. Okay, and earlier to study of these rectifiers, so initially we'll see the parameter is to be concerned for the rectifier here. Okay, so that if you take the parameters of the rectifier, okay, so if you take the ripple factor and the ripple frequency, okay, the efficiency, it is peak inverse voltage and the regulation are all the parameters of the rectifiers here. Okay, so that if you see so if you see the definition of the ripple factor, it is the amount of the ripples present at the output of the rectifier. It is itself is called as the ripple factor. I think you know, yeah, I think you know the definition of the ripples here. It is the mixture of the it is a DC as well as the some amount of the AC. It is at the output of the rectifier. So how much amount of the ripples it is having, its measure itself is called as the ripple factor, and it can also be defined in the another way. So it is the ratio of the AC voltage at the output to the DC voltage at the output here. And if you take the ratio of that one, it is also going to give you the ripple factor here. So the amount of the AC voltage present at the output of the rectifier is to the amount of the DC voltage at the output of the rectifier itself is going to measure the ripple factor here. And if it is to be represented in terms of the formula, okay, so the ripple factor R is equal to under root of IRMS divided by IDC whole square minus 1. It is going to represent the formula in order to calculate the ripple factor of the rectifier here. Okay, and if you see the another parameter, it is ripple frequency. It is the vibration of the pulsating DC, and it is to be measured in terms of the cycles per second or in terms of the hertz here. So it's nothing but it is going to represent the frequency of the pulsating DC signal. Okay, and it is itself is called as the ripple frequency. So it is the vibration of the pulsating DC signal, and it is to be measured in terms of the cycles per second or it is to be measured in terms of the hertz. It is itself is called as the ripple frequency here. Okay, and if you see the another factor, it is an efficiency. So the efficiency, it's nothing but the amount of the output, okay, is based on the applied input. So it is defined as the amount of the DC power obtained at the load, it is to the AC power applied at the input. It is itself is called as an efficiency. And if it is to be represented in terms of the formula, it's nothing but the output power divided by the input power. Already you know that in case of the rectifier, the output will be in terms of the DC, the input will be in terms of the AC, so that if you want to calculate the efficiency, the output power divided by the input power is going to represent the efficiency of the rectifier here. Okay, which is to be indicated as of the PDC divided by this PAC. And if you take the peak inverse voltage, it is going to be represent the maximum reverse voltage. It represents the maximum voltage the diode it must withstand under the negative half cycle. Okay, so I think you know that the operation of the diode is to be get operated only under the forward bias. So, but under the negative half cycle, what happens? The operation of the diode will be under the reverse bias. So, under the reverse bias, so it is what is it's the maximum withstanding voltage. This to be considered. It is acting as of the peak inverse voltage here. Okay, and the another parameter is the regulation. It's nothing but the variation of the DC output voltage as a function of the DC load current. That is itself is called as of the regulation. So that means that initially, so the voltage is to be calculated. It is without the load, and after applying the load, also the output voltage is to be considered. And if you take the difference of that one, it is itself is going to measure the regulation here. Okay, so that if you take the parameters of the rectifier, so the first is the ripple factor. It is the ratio of the AC voltage at the output to the DC voltage at the output. And the another one is the ripple frequency. It is the vibration of the pulsating DC signal. It is to be measured in terms of the cycles per second. And the another one is an efficiency. It is the ratio of the output power to the input power. It is the ratio of the output DC power to the AC input power. Okay, if you take the peak inverse voltage, it is going to be indicating the maximum reverse voltage. So the diode can withstand is called as the peak inverse voltage. If you take the regulation, it's the vibration of the DC output voltage as a function of the DC load current is called as the regulation. Okay, and it is based on all these parameters. So the actual efficiency of the rectifier is going to be measured here. Okay, and we'll see the types of the rectifiers now. So already you know that. So the rectifier is to be classified into of the main three types: half wave rectifier, full wave rectifier, and the bridge rectifier. Okay, so initially we'll see the half wave rectifier here. It is what's the half wave rectifier. So the half wave rectifier, it is going to conduct only for the half cycle, and in another half cycle its output is going to be the zero. It is itself is called as an half wave rectifier. And in order to build the half wave rectifier, okay, it is going to make use of the one transformer, and it is one diode, and it is one load register. Okay, so initially the voltage from an AC is to be applied as input for the transformer primary coil, and if you take the secondary coil, it is to be connected for the anode of the diode, and for the cathode of the diode, it is to be connected with the resistor, and the other end of the resistor is to be connected again for the secondary coil in order to form the closed loop here. Okay, under the positive half cycle, what happens here? The arrangement of the diode, it is going to be the forward bias, and if it is going to be the forward bias, it is going to do the conduction, and if it is going to do the conduction, the voltage at the secondary coil is going to be appear across the load here. So under the positive half cycle, if you apply as an input, and the output is equal to the exactly same, which is equal to the positive half cycle. And under the negative half cycle, what happens? The arrangement of the diode is assumed to be the reverse bias, and if it is to be the reverse bias, means it is assumed to be then open circuited, and if it is assumed to be an open circuit, means the output voltage is equal to zero. So for that purpose, you can observe in the waveforms here. Also under the negative half cycle, this output is going to be the zero. Okay, and in this way, it is going to be continued for the succeeding cycles. Okay, so if the operation takes place in this way, and itself is called as an half wave rectification here. Okay, so the half wave rectifier, it is going to be conduct only for the half cycle. It is under the positive half cycle, the arrangement of the diode is going to be the forward bias, and in which the output voltage is equal to the input voltage. And under the negative half cycle, the arrangement of the diode is assumed to be the reverse bias, and it is acting as an open circuit here, and its output voltage is equal to zero here. So under the negative half cycle, output voltage is going to be the zero. In this way, it can able to conduct only for the positive half cycles, and under all the negative half cycles, the output is equal to zero. It is itself is called as an half wave rectifier circuit here. Okay, so I'm going to end up this class here, and we'll continue with the full wave rectifier in the next class here.